Welcome to Global Marine Network's overview and tutorial of the Optimizer Crew Satellite Wi-Fi Router, a powerful, reliable, and affordable solution for multi-person networking on most satellite broadband installations. This powerful router gives you everything you need to provide and manage email and internet access for crew and passengers on your vessel. In this presentation, you will be hearing from Dr. Louis Soltero, CTO and President of GMN, who has a PhD and Master's in Computer Science. Louis is the developer and Director of Software Development for Global Marine Networks. To access the UI, the user interface, first power on the router. Second, either Wi-Fi connect to the router or use an Ethernet cable to connect your computer to one of the 4 LAN ports. Third, the Wi-Fi SSID is small w, capital X, small a, -115-XXXX, where XXXX is the last 4 digits of the unit's MAC Ethernet address. There is no password. Fourth, once connected, open a web browser and go to the following URL: http://10.1.5.1. A login screen should appear. The username is admin and the password is webxaccess. Procedures for powering and configuring the router are described in detail in the startup guide included with the router or available for download from www.redportglobal.com. Now, here's Louis.
Once you log in, you gain access to the web UI for the router. Now, before I actually start talking about the web UI for the router, what I want to do is I want to talk a little bit of theory of operation in the router. So the router is more than just a router. The router actually has some enhanced proxy servers on board or services that run on board in addition to doing basic routing. So there are 3 major components to the Optimizer Crew. One of them is the captive portal. So the captive portal is a major component of the device which blocks access to the internet unless authentication is provided by an end user, and that authentication can take place as either a PIN code, a username and a password, or the MAC address of a specific PC. So before anyone can access the internet through the LAN port or through the Wi-Fi, they have to log in, and there's one account that's created by default, which is the admin account. So you can always get into the router using admin webxaccess as a password. But the first thing you'll want to do is log in, change the password for the captive portal, and then start creating accounts for those users. Of course, you can disable the captive portal and not use the captive portal, but by default, the router comes with the captive portal enabled. In addition to the captive portal, there's an internal proxy server. This is an HTTP and HTTPS proxy server. It does URL and DNS filtering. So, for example, you can create whitelists and blacklists of sites that users are allowed to go to. It does some content filtering. For example, you can have it remove flash video from your HTTP stream. And it knows how to communicate upstream to an upstream compression proxy server. So it provides compression services as well. And so it's basically one of the major components for dealing with HTTP. You can also turn on some basic HTTP logging so that you can see what URLs are being accessed by the end user. The third component or major component is the firewall. And of course, it has a full-featured firewall that does everything you would expect a firewall to do. It blocks ports, it allows ports, it IP addresses, IP ranges, port ranges, different kinds of protocols, and so forth. And that firewall can be applied to any path going in and out of the router, and we'll show you how that works. But what I'd like to do right now is, now that I've introduced the 3 major components, is talk about the data flow through the router. It's important to understand how the data flows through the router so that you can customize the configuration. By default, the captive portal is enabled, the transparent proxy server is enabled, compression is disabled, and HTTP data flows from the captive portal to the proxy server and out to the internet. That's the default configuration. And so when you turn it on, you Wi-Fi connect to the unit, you get a username and a password for the captive portal, you log in, and at that point you should have direct access to the internet and be able to use the internet. And so that functionality right there will work for 99% of the customers. Let me talk about the data flow. So the first thing is the captive portal. That's the thing that the user that's facing the user. Once a user logs into the captive portal, data can transfer through the router in 3 different paths. So first one is non-HTTP traffic, goes straight onto the internet. DNS lookups, HTTPS, FTP, SCP, non-HTTP traffic. So non-web traffic, and that includes HTTPS traffic. So by default, HTTPS, FTP, SCP, ping, DNS lookups, anything that is not HTTP by default gets transmitted directly onto the internet after the user has logged in. There are firewall rules that are totally open, and so there's no blockage to the internet. So once the user puts in a username and a password, he can run Skype, for example. He's got full access, full reign to the internet through the captive portal. Now, the captive portal can limit his bandwidth. So he can say, you can access the internet and you can run Skype, but you're only going to get 64 kbps, and you're only going to get 200 megabytes. And after that, we're logging you out. So you've got some control over the speed at which the connection runs for the captive portal and how much data gets used by that particular user. And of course, you've got CDRs, which I'll show you for these transactions. And so you can see how much data a specific user actually used at what different time intervals. And then, of course, you can control the speed. But by default, the firewall is open. And so all of that traffic goes straight onto the internet. It's accounted for, but it's not blocked. Now, of course, you've got a firewall, and you can block traffic from that particular user or for a particular port or for a particular destination. And so you've got full control over what traffic is allowed after the user has authenticated in the captive portal. But by default, the firewall is open, and therefore all the traffic is transmitted. Only HTTP and in some instances HTTPS get proxied. Non-HTTP, non-web traffic does not get proxied. It goes straight onto the internet. The captive portal has the ability to whitelist some specific hosts. And by default, for example, all of our servers are whitelisted. If you whitelist a host in the captive portal, that means that the user can access that particular host without having to log into the captive portal. So for example, if you were running Amos Mail, all right, or Skyfile, or some service that you wanted to have the end user have access to without logging in through the captive portal, then you could whitelist that server, and data is transmitted to that server over the internet, barring any exceptions that you have in the firewall, without any filtering. So hosts that are whitelisted never see the internal proxy server, and that's important to know. So if you whitelist a web server, you will go straight to that web server with no filtering at all, period. And that's an important thing to note. Typically, you wouldn't whitelist a web server. Typically, you would whitelist a mail server of some sort for mail processing, or for, maybe a VPN, or for something like that. But if you do whitelist a web host, that web host will be accessed without being interfered by the proxy server. There's no filtering at all. So basically, all the content from that remote website gets transferred to the end user without modification at all, period. So that's an important thing to know about the whitelist in the captive portal. Now, by default, the box has something called transparent proxy enabled. And transparent proxy means that any traffic that is headed through port 80, which is the HTTP port, gets hijacked by the router and redirected to the internal proxy server. So the user needs to make no changes to his web browser at all. He's just going to go to google.com, or he's going to go to bbc.com, or he's going to go to some website. As his request goes through the router is going to intercept that request. It's going to hijack it, and it's going to redirect it to the internal proxy server. That's called transparent proxy. Now, one thing to note is that transparent proxy can only happen for HTTP traffic. It cannot happen for HTTPS traffic. You cannot hijack an SSL transmission because SSL will detect that as a man-in-the-middle attack and will prevent the traffic from working. And so we can't hijack HTTPS or secure traffic. We can only hijack non-secure HTTP traffic. Now, you can block HTTPS traffic from the firewall, and then the user would never be able to go to their banking website. So typically, you don't want to do that. Now, if you're really worried about reducing the amount of traffic, we can proxy HTTPS, but that requires the end user to make modification to his web browser. And we will talk about that configuration, because in the default configuration, where you want the user to be able to use secure websites with transparent proxy without making any changes to his browser, things like Skype will work, because Skype will use port 443, which is the SSL port, and it'll just go out onto the internet very happily and allow people to chat over the HTTPS port. So this particular setup, which is the default setup, which is going to work for most everyone, has HTTPS enabled. It doesn't proxy HTTPS because it can't, because we're using transparent proxy, but it's not the most bandwidth efficient way to run your router, because you must have DNS enabled and you must have port HTTPS enabled in order to be able to browse secure websites. In a different configuration, which I'll show you and we discuss in the quick start guide, we can close all the firewall ports. We can make some modifications to the web browser for the user and allow them access to HTTPS and HTTP and DNS without actually having those ports open, which will block all traffic except for through the proxy server. But that's a more advanced setup. But I'm just talking about the flow here. Just know that in transparent mode right now, which is the default setup, HTTP traffic is hijacked to the proxy server. So we're looking at this route right here for HTTP traffic. We understand how the traffic flows. And of course, we've got firewall rules there that can basically block traffic to the proxy server if you want to prevent one particular user from accessing the proxy server and HTTP traffic, for example. So we're in the proxy server. Now, the proxy server, as I stated before, does a number of different things for you. One of the important things it does is URL blocking and domain blocking. So, for example, you can say block all traffic to any Google server. So, for example, you can create a rule that says block.google. So any URL or any domain that has the word Google in it, for example, will be blocked. So you can create whitelist and blacklist of hosts and URLs. So, for example, you can allow certain specific URLs at Google to work, but not others. And there's an entire set of rules that you can use for building these whitelist and blacklist for matching patterns and so forth that allow traffic to go through. But this is very powerful because administrators, for example, can whitelist a corporate website or a payment portal for their crew and block everything else. And so that particular user would be able to access those particular websites once he logged in through the captive portal, but he couldn't do anything else. Or you could, for example, filter out Flash. And so they can go to YouTube, but they can't watch the videos because Flash is being filtered. So there's a number of different things that you can do at the proxy filter. It does some content filtering, not much, and it does URL blocking and domain blocking. Those are its main purposes in life, are to do that. The other thing that it can do, of course, it can speak to an upstream proxy server to provide compression. So let's examine the different scenarios for traffic flow. So if you look at the blacklist, for example, that's one of the things you can blacklist hosts. Those hosts will automatically be blocked and not transferred. That's this guy right here, right? So that's basically your blacklist. Another thing that you can do is you can enable compression. To enable compression, now that's a for pay service that we charge for. Then all HTTP traffic by default will be transmitted to an upstream proxy. That's this guy, that's this path right here. That traffic will go upstream to an upstream proxy server, which will do a number of different things for you. It'll strip out all ads. It will compress all text into gzip streams. It will resample the images down to considerably smaller than the original size. And of course, the proxy server will allow you to set the compression level on the images. It'll condense and compress JavaScript. It will flatten out images. It will do a bunch of things that are going to optimize the HTTP traffic for this particular account. By default, we get a 3 to 5x compression on regular HTTP traffic. And so the bandwidth utilization is considerable when you have compression enabled. So that means that if you're on a BGAN plan at $7 per megabyte, you end up paying $2 per megabyte for your data effectively. So it increases the speed of your connection, and it also decreases your effective per megabyte cost of your connection. To enable the compression, and we'll see that when we go into the UI, how you enable the compression. But basically, when you enable the compression, all HTTP traffic will go upstream to the HTTP server for compression, unless you specify that a specific host is not to be sent upstream. You whitelist that host, in which case that host takes this path up here and goes straight to the internet. And the reason for that is because the compression's aim is to give you some reasonable facsimile of the original page, but it's doing dramatic stuff to that page. And on some websites, the rendering isn't perfect, and so they don't render perfectly. And so for some websites, it's important to whitelist them. This is especially true when you're proxying HTTPS, which we're not doing right now. When you have a page that has HTTPS and HTTP elements, sometimes that page doesn't render correctly because you're taking one path for HTTPS, you're taking another path for HTTP, it's compressing it, and the page doesn't render correctly. And so often for like secure banking websites and so forth, especially if they need one IP address to be the source IP address and not two different IP addresses, it's important to whitelist those. And so let me go over that again. If you have a scenario where you're using HTTPS to get to a banking website, that page has HTTPS and non-HTTPS elements. So the HTTPS IP address is going to be the IP address of the router because it's taking this path right here to get to the secure website. However, you're proxying HTTPS, which is taking this path and going to an upstream server. So the IP address for the HTTP traffic is from a different server. So that means that when the requests come into the secure site, you've got requests coming in for that particular user from two different IP addresses. The HTTP gets one IP address, the HTTPS gets a different IP address. A lot of banking websites will throw their hands up in the air and say, hey, something weird is going on here. I'm not going to display this page. And so they don't work. So in that situation, you would whitelist that particular web page or that website so that all HTTPS and all HTTP traffic comes from one IP address, which is the source of the router. There's no rendering issues, and the website will work correctly. And so you've got this whitelist of Proxy Server here. And so as we go through the configuration for each one of these components in the routers, you'll see that there's sections for the whitelist. And again, I would refer you back to this diagram you can refer to on how the paths are for the different elements in the router. But that's pretty much it. So we've got those three components, and that's how the data flows through the Optimizer Crew router. We ship the router with the captive portal on and transparent proxy. That works out of the box. Anybody can basically at that point create pin codes and track their users, see how much data they're using, limit their amount of data that they're transferring, and they get to go in and create whitelists and blacklists for whatever websites they want to use. That works for everybody. Now what happens is if you have a particular customer where they're putting this on vessels with low plans, like the standard plan or the small vessel plan, this is not a good scenario for them, right? Because they're paying, $12 or $13 a megabyte, and they've got DNS enabled, which generates a lot of traffic, and users can burn up their PIN codes way too quickly because they've got no compression, and as soon as they put in their PIN code, Windows updates and everything else that's happening on their computers are going to want to go on the internet. So what they will do then is they will have some knowledgeable technician, someone who's been through training and someone who knows about proxy servers and routers, go through and generate a custom configuration for them where they've enabled the firewall to block things, they've configured the proxy server to tune things, and they've enabled upstream proxy, and then they'll record that setting, and then they'll clone the routers as they ship them out so that they're in the standard configuration, which will give them much better optimum performance. But by default, you get some performance, mainly in the fields of monitoring and blocking using the captive portal and using the proxy server. Okay, so we've logged into the router. Now, the router currently is not a multi-user router, it's a single-user router. There's actually two accounts on there. There's an admin and a super admin, but we're dealing with limited resources, and so we don't have the ability to create multiple users here. So the idea is that the captain will log in, using admin. Okay, and he'll land into this home page, which has tasks for that particular administrator, which is going to be generate PIN codes, create users, and look at CDRs for the captive portal. Use webmail to go check mail if they're using the mail server functionality on this particular router. Create and manage crew accounts, so create email accounts for the particular users and manage mail. And then look at some status information. For example, we can actually monitor historic bandwidth for the router. We keep track of up to a year worth of bandwidth usage over the interfaces. So for example, they can see that this last month they used 50 megabytes, but the previous month they used 10 megabytes, and then they can wonder why they're using so much more data now than they were before. And so there's a bandwidth management. I'll just show you that real quickly since that's pretty straightforward. So here is our WAN usage over the last hour, and we've used 300 kilobytes so far in the last hour, and that's just basically because I'm using the web interface. But I can come back here and take a look at the last month, and that will show me utilization over the WAN port over the last month. So I can keep track of. So I basically looks like I've used a total of 97 gigabytes through this router over the last month. That's kind of useful. All of the services that are on the router are on this next tab, which is basically the services tab. So the way the router works is you've got main categories, which are driven by the top level tabs. And once you select the top level activity or section, then you've got sub levels, which are the next tab level. So here you've got the captive portal, web compression and filtering, which is the proxy server, the email servers, GPS tracking, the NMS repeater, and some control for handsets that are plugged in through the USB port. And then once you're in each one of these particular categories, there's submenus which are specific to that category that pertain to that particular subsystem. Crew internet access is the captive portal. So you need to know that. Web compression and filtering, that's the proxy server. So you need to know that web compression and filtering is the proxy server. Red port email is the mail server, the POP, SMTP, and webmail server. The GPS tracking, subsystem, NMS repeater, and so forth. So let's take a look at the crew internet access section first. Well, first of all, you've got some general settings that pertain to the captive portal. This is how you set up the captive portal. By default, the captive portal is enabled. You could disable it. And again, transparent proxy is enabled. You can disable it. This one check mark controls the path right here, this transparent proxy path right here between the captive portal and the proxy server. So if you have that unchecked, then all traffic from the captive portal goes straight onto the internet. It doesn't go to the proxy server. If you have it checked, then HTTP traffic goes to the proxy server. And of course, you can customize the name of the hotspot. So as when the user's logged into the hotspot, right now it says red port hotspot, which is basically the default name, but you could say, welcome to ship, blah, blah, and you could just basically do some minor customizations to the look of the page that is presented to the user when he logs in. The login page is very simplistic. Basically, it's all text and has a little red port logo on it, and you can change that title on the top of the page to something other than red port hotspot.
Just a quick clarification here. If the first one is enabled, that basically controls access. If the second one is enabled, it then takes it onto the shore side server as well.
Yes, that is correct. Well, this is transparent proxy. That means that if you want to hijack all HTTP traffic and compress it, you need to have this check mark enabled. If you disable this check mark, the top one, the captive portal, then basically you've got a standard router. It has a proxy server, and you can do transparent proxy. At that point, nobody's logging in. You can still get compression. You can still get proxy filtering. But you have free reign access to the internet without having to log into the captive portal to use it. So if you uncheck that, you've removed this entire circle that says captive portal. And so now your traffic goes through the firewall to the internet, or if you've configured the proxy server for transparent proxy, HTTP traffic will go through the proxy server. So you don't have to have the captive portal. It doesn't have to be enabled. We suspect that most users want the captive portal, which is one of the reasons this product exists, because there has been a drive for inexpensive prepaid PIN code access to the internet. And so by default, it's enabled. Just because you've got the proxy server enabled doesn't mean you have to have compression enabled. So you can still get the benefits of the proxy server. You can still get web filtering. You can block sites. You can enable sites, block sites. You can filter some content you're just not going to have compression. And let me just jump. So if you go to the proxy server, right, by default, you'll notice that web compression is not enabled. So you don't get compression by default, but you still have the ability to filter, right? So you still have the ability to control, let's see, the amount of filtering that you have. So for example, you can say that you want to be very aggressive with your filtering, which will basically block YouTube and Flash content and so forth. So you still have the ability to do some basic filtering, but you don't get compression. So that's the default. By default, you would want the captive portal enabled and the transparent proxy enabled. The web compression in the transparent proxy is disabled, so you get no compression, but you still get filtering. So that's going to work for everybody. Now, if you enable compression, now you need a username and a password, which we provide you, and that's going to cost you $50 a month. You got to keep in mind, so we've got captive portal, we've got the proxy server, so that transparent proxy checkmark controls this one line right here, and then the compression checkmark controls that line right there, which is one of the reasons I basically displayed the diagram for you, because you need to understand that in order to be able to start modifying this router. Okay, so if you want to enable compression, you would go to web proxy filtering and you would say enable compression. And then you would come down here and put a username and a password. No need to mess with this one right here. In this configuration, the way I've got it right now, the compression server will log in on your behalf and you will be able to use a compression server. With this check mark, what happens is the authentication doesn't happen at the router, it happens at the client. And so when you go to google.com, you'll get a login prompt which will require you to put in the username and password on the browser itself. So by default, you really don't want that. What you want to do is you want to just basically enable compression and put in a username and a password, and then you would hit save and apply. Again, you would specify the amount of compression that you wanted. So usually maximum if you're on a low plan. If you're on an all-you-can-eat plan, then probably standard would work fine for you. And here's my whitelist, right, for my compression. These are sites that I don't want to compress. So I would just add them here. We're going to bypass compression for sites that are listed here in this list. And so you would just add them there. You could add google.com if you didn't want, for example, to compress google.com for the reasons that I mentioned before, where you...
Why have you called it bypass regex domain?
The reason for that is because it's not just domains, not only hosts, but it's actually URLs. So for example, you could allow cnn.com/world, right? You could just block cnn.com/world and allow that one to bypass the compression, but all the other CNN ones to be compressed. Everything is a regular expression. In other words, you can put in stars and different matching patterns to kind of expand the list of things that you want to filter. And so there's shorthand notation. You know, like when you're on a PC back when you were doing DOS, you could say dir star dot star, right? Yep. So just basically in the star is a wildcard. Well, you can do the same thing with all of the proxy server domain and URLs, and those are known as regular expressions. And so you can enter regular expressions that allow you to condense, instead of listing 1,000 sites, just to condense it to one site, which is basically a mixture of stars and dots and question marks and things that allow you to optimize the definition of what it is that you want to allow or block. Under general settings, so this is just basically for the proxy server. This is enable, disable the proxy server. If you disable the proxy server is out of the picture. It's not there. And then enable transparent proxy. This is to enable transparent proxy if the captive portal is not enabled. So you'll notice here it says, note this model is not compatible with the captive portal. Captive portal, if enabled, will disable this particular feature. And the reason for that is because the captive portal will automatically do the transparent for you if you've got it on. But if you're not running the captive portal and you want transparent, then here's the check mark that you would use to enable that. If you go back to the captive portal, you'll notice that there is an enable transparent routing right here. See that right there? So when you've got the captive portal enabled, the transparent proxy is handled by the captive portal. If you've got the captive portal disabled, then the transparent proxy is handled here if you want it. Back in this diagram, it allows you to totally remove the captive portal if you don't want it. It allows you to totally remove the proxy server if you don't want it. And then, of course, you've got the ability to transparently proxy in either case, if the captive portal is there or the captive portal is not there. If you remove both components, then you only have the firewall, and at that point, you might as well just go to your local retailer and just buy a D-Link router. All right, so let's just get back to the captive portal real quickly here. So I'm back at the captive portal. Advanced settings, really nothing you should mess with there. I'm not even going to go over it. There will be a manual which describes basically what all this does. Allowed hosts, this is the whitelist for the captive portal. These are the hosts that you're allowed to access having to log in through the captive portal. And by default, there's a number of hosts there, and those are all GMN hosts for our services. So you can do email, you can do voice over IP, you can do all of the things that we provide without having to log into the captive portal. If you don't want those, you can just delete them. You could add, if you're Inmarsat and you're using Amos, then you would add the Amos servers there, and then you could basically go through. WPAD, I am going to come back to. This is a very special feature for auto-configuring the proxy settings on the client's web browser for much tighter control over access to the internet. But that is an advanced topic, which I'm not going to talk about right now. Okay, so that's basically the settings.
Question.
Sure.
Concerning the web proxy.
Yes.
Is it possible to block all the sites except a couple?
Yes. Go back to the proxy settings. You would go to filters. And so here are all the sites which should be blocked, right? So for example, I could put in the word .update . Any URL that has the word update will be blocked now. So if I wanted to block the entire internet, I could just put a slash in there, right? So any URL that has a slash is going to be blocked. And then I could come down here and I could say, okay, allow Google. Now, this particular rule up here blocks everything. And this rule down here says, okay, now that we've blocked everything, allow Google. And now you can access Google. Anything that has Google in it will work, but nothing else will. So again, this is back to our regular expressions. We can talk about that when we discuss the proxy server, but by default, you have control over what sites are blocked, what sites are allowed, and some content filtering with the proxy server without having to enable compression. Okay, the rest of the tabs here, so the first one is for settings. The rest of the tabs here are for managing users and PIN codes. So to create a user, I can add a user here, test. 1, 2, 3, 4, 5, 6. When I hit save and apply, that will create a user so that when I'm presented with the captive portal, I can log in as test1 with password 1, 2, 3, 4, 5, 6. I can control how many megabytes that guy gets. So if I do this, the guy gets to log in and he gets to use 200 megabytes, and after that, he's not allowed in the router. I can set a reset period. Now he has 200 megabytes that is good for a month. At the end of the month, at midnight, he will get cleared out, and then he can log in again and have 200 megabytes for another month. You can allocate quota for that particular user on a daily, weekly, or monthly basis. You can specify how fast that user can run, 96 kbps. If you specify 64 kbps, then that user can browse the internet fairly slowly, but he will never be able to do voice Skype, right? Because voice Skype requires 100 kilobits per second. And so he won't be able to talk over this connection, but he'll be able to browse the internet and he'll be able to do Skype chat. Idle timeouts are exactly that. An idle timeout means that if the user doesn't use any network traffic within that specific period, he will be logged out automatically. And a session timeout means that after X number of seconds, 3,600 an hour typically, the user is going to be logged out forcibly and he will have to relog back in to use the system. Say, for example, you set the session timeout to 3,600. Okay, just like that, right? That means that that user can log into the internet, use the internet for an hour, and after an hour, he will be forced off of the internet. He will then get the login screen, and he'll have to log back in. The only reason you would want to do that, really, is to make sure that he doesn't have a computer that is chatting in the background, right? So it could be that he's running Skype in the background, which is always running. He's not on his computer. Skype is running and consuming bandwidth, but he's not at his computer. The idle timeout isn't going to log him out because Skype is sitting there busily transmitting data back and forth with all his peers. But you want to force him off because the guy's not using the computer. And so by setting the hard timeout, you force him off, and now Skype stops working. He comes back to the computer and goes, oh, I've been logged out. I need to log back in to use the internet, and then he logs back in. So the hard timeouts are really kind of nice because they will force that session to end regardless of whether the traffic is going through or not. It's a little irritating to the users if you make it too small because then they have to log back in. It also creates a new timestamp in the CDR. So again, that shows up in the CDR. So for Instead of having a CDR that is like covering a week, then you would get CDRs that basically have 1 hour intervals. If you set this to 1 hour because the user is forced to log out, when he logs back in, he gets a new CDR entry.
Is there any other area which allows us to control them to how many hours of access they have per day or whatever?
You can do it with users and username and passwords, or you can do it with PIN codes. For users, you don't have control over what time of day they can use the system.
Okay.
For PIN codes, you do.
Right.
Users are like the captain or the first mate, people that are on the boat all the time that are kind of important people. PIN codes are for crew that are transient and shouldn't have permanent accounts on the system. So PIN codes are disposable and users are more permanent. MAC address basically allows you to whitelist a specific host. I don't have any Wi-Fi devices connected to my thing. If I did, basically they would show up there and I could actually go ahead and just whitelist the captain's computer. And so captain would have full access to the internet without ever having to log in, put in a username, a password, a PIN code, anything. He would basically be whitelisted through the captain portal. A dangerous thing to do. I wouldn't recommend this. The only reason this exists is because they have bridge computers and they don't want to have the people that are on watch on the bridge to have to log in through the captain portal. They were afraid that if they gave a username and a password for that particular computer, then the crew would just take that username and password and just go down below and use that with their computers down below. And therefore, they wanted to have this MAC list web address. So that's why that's there. But you can just take any computer and just allow that computer access to the internet without having to log in. You just copy the MAC address and just paste it in. It's a little inconvenient, but that's it's not terrible. And since it's an operation that you're doing fairly infrequently, it's not that big a deal. Okay, PIN codes. Now, this is really kind of like the meat of the captain portal. This is where things really get interesting. PIN codes are disposable. You just generate them on demand and give them to whoever you want to. There's instructions here on basically how to generate the PIN codes. You select the number of PIN codes that you want. I'm just going to generate one PIN code. This is just a textual reference for you, which basically allows you to maybe categorize the PIN codes for you so that you can just generate the PIN codes now and then have a bunch of them in inventory and then just kind of be able to identify what they are by some number that you specify. Again, you've got a quota, so we're going to generate 75 megabyte PIN codes. Reset, these are good for a week, so this particular PIN code will be valid for 75 megabytes. At the end of the week, it'll reset so they can use them again. You can control the speed, and you can control the time of day. All right, so this particular PIN code will be valid from 0500 to 0800. I push the button, that generates my one PIN code. There it is right there. And if I push the download button, that'll download a CSV file with that PIN code in it. And then I can just put that in inventory. So here comes Excel. I just opened this up. There's my PIN code right there. So I have it there. I've got it stored. And now I can hand those out to the crew. So the user would enter this particular number into the captain portal login to log in. And then he'll only be able to do it between 0500 and 0800. And those are in router times, by default GMT time. But of course, you can change the time zone for the router, in which case then it would be valid for the local time on the router. And if he tries to log in after hours, the captain portal will say, sorry, you're trying to log in after hours. We're not going to allow you in. Otherwise, he's allowed in. At 0800, he will be logged off forcibly, no matter how much is left on his PIN code. CDRs, if you put in a PIN code, I'm just going to put in the admin username, or you put in the PIN code or a username or the MAC address for a particular computer. Basically, that will generate for you a CDR for that particular user or for that particular account. The very first section of the table basically gives you the name of the user or the PIN code, and it gives you a summary of basically the parameters for that particular PIN code or for that account. And then you get the CDRs. You get the time they logged in, how long they were logged in, the total number of bytes that were transmitted, the number of bytes in, the number of bytes out, the IP address that was allocated to that computer, and the MAC address that was allocated to that computer when they were doing that session.
So in the username and PIN code section, I could use the username, the PIN code, the MAC address, or the IP address as well?
That is correct.
Wow, wonderful.
Everything has CDRs. Anybody who logs into the captain portal has a CDR. And so you can see how much usage that particular user has had through the lifetime of the router. Now, things that you can do, for example, is you can wipe out the CDR. So if you push to remove CDR, so for example, say you've got a user and he's exceeded his quota, you can just wipe out the CDRs for that particular user, and then he'll be able to log back in. And then, of course, the download button allows you to download the CDRs in CSV format. Yep. So there they are, so that you can mail them back to headquarters or whatever you want to do with them. Or if you wanted to bill somebody for their usage, well, you would sell them the pin code. You would just sell them a 20 megabyte pin code and say, okay, that's $100.
So you're saying if you remove the CDRs, it will also offload the quota of the crew?
That is correct. The quota comes from the CDR. So if you delete the CDRs, then there's no accounting. This is the accounting. So this is how it knows how much data has been used. So if you wipe out the CDRs, then that pin code is now valid again. Under Tools, you can change the admin password. Now, this is not the admin password for the router. This is the admin password for the captive portal. It happens to be the same as the admin password for the router. When you get the captive portal, you can put in the word admin with the password WebEx access, and it'll let you in. That's what these CDRs are all about, right? If I go back to CDRs and I type in admin, there is an admin user who is not visible, which is known as the administrator for the captive portal. That's just an account that we just created by default, which is totally open, so that you can log into the captive portal without having to have a username and password created for you. If that gets out, then of course you've lost security, so you probably want to change the password, set the password for that. Reset DB, that just wipes out the entire database and sets it back to factory defaults. Purge expired pin codes. As your database continues to build, occupying space and taking resources and slowing down your captive portal, you can just basically push that button. That'll just purge from the system all expired pin codes. You might have a bunch of pin codes. You know, you generated 1,000 pin codes. You only have used 100. There's 1,000 of them sitting there. You can purge unused pin codes if you want to. And then there's this manage pin codes feature, which is a really nice feature. If you push that, it'll show you all the pin codes and all the MAC addresses that have been listed on the server. Here's a test account that I just created. There it is. Here are some pin codes that I've generated on the system and how much they've used and what the reset value is, and so forth. I can delete them from here. So if I just go here, for example, and just push that button right there, it says delete, I will have deleted that particular pin code. So it's gone from the system. Or I can hit reset at any one of these, for example, and that will reset the quota for that particular user by deleting the CDRs. It can be done remotely or it can be done on the vessel. This particular router is different than our other routers. First of all, the intent of the captive portal here is that it's local. There are no server-side resources, so anybody can use it. It's airtime independent, it's provider independent, it runs on the router. The bad news is that all the database and everything and all the CDRs run on the router. They're not upstream. Our other routers, our more expensive routers, basically have a captive portal that keeps track of all this information on the shore side. So administrators can actually generate pin codes, view CDRs, and manage the CDRs much the same way we're doing here on the shore side. But those routers are a lot more expensive, and they require shoreside servers to keep track of all this information. They also require more bandwidth because all the accounting information for the captive portal is being sent upstream over the link to the database. So if you want to have shoreside functionality for this particular feature, then really you either need to buy one of our more expensive routers, or you need to log in remotely and do this remotely on every router that's in your fleet. To put this into perspective, the WXA 303, which is our standard ship-based router, which is all you can eat, certified and all that, is $1,400 retail. So gigantic differential price in the router. That's pretty much it for the captive portal. I mean, it's as you see, it's very powerful and very flexible. And I believe that this will be the killer app for this particular router. Web compression and filtering. Okay, wow, we've talked a lot about this already. I wanted to do this in sequence, but you know, we know what the compression tab does. We know what the general setting tab does. Under advanced, the only thing here that might be of interest is the default filtering scheme. And this is where once the pages come down from the upstream proxy or from the internet, the proxy server tries to remove elements to optimize, and we've just come up with some categories that do little, moderate, or a great amount of damage to the page. And so you can play around with these settings. The aggressive one, of course, is going to give you the best bandwidth consideration, since that's going to be removing the most amount of stuff from the web pages and not delivering it to the end user. And then the light, of course, has the least impact. Other than that, there's really nothing in here to mess with. The only thing that I'm going to mention here is under the debug level. If you add the debug level of 1, then it'll log all the URLs. So as users are using the internet, you will see a log of all the URLs that they access, and those will show up under the log section. And so you'll see 1 line per URL. I wouldn't recommend running that operationally. The log files are kept in RAM, and so eventually what will happen is RAM will fill up, then the swap partition will fill up, and then the router will crash. So you wouldn't want to operationally have this on all the time, but for debugging purposes, to see that indeed the proxy server is working as expected and that your whitelist and your blacklist are working as they should, you can enable the debug levels and then see those URLs in the log files. We talked a little bit about the filters. There's 3 categories here. One of them is called the fragile sites. These are sites that basically you should not mess with the content. In other words, web page comes in, you just pass it on without actually mucking with the content of the page itself. And then, of course, we talked about the sites, which are blocked and allowed. The expressions, what you enter here to block, for example, is all defined in the help file. If you look in the little help section there, basically talks about the different debug levels, and then it talks about the syntax for the patterns. And you've got domains and paths. So you've got domain syntax and some examples on how you can filter by domains and domain expressions that are valid. So for example, add star.example.com removes anything that starts with the word add, has anything followed by example.com, etc. And then of course you've got the path syntax, which describes the syntax for the actual URL in the path past the host name. And I'll just let you read and play with those, but it's, like I say, very flexible. POSIX regular expressions are what are used, and that just is a quick definition. A quick Google on POSIX regular expressions will give you all kinds of tutorials and so forth that can be used there. I think most people will be entering things that look like www.example.com or maybe something that looks like star.example.com, and that's all they really need to do. Under the captive portal is IP addresses. So you specify the host name or IP addresses or a range. So the captive portal whitelist is not anywhere near as flexible as a proxy whitelist. They use different syntax. The rest of this stuff is fairly interesting. Redport email, we do have a full-featured crew solution that runs on the router. So you can manage email for the entire crew using compressed email with blocks, with MIDI file, restart, and so forth. A lot like Amos, except that it's running on the router itself, and users can log in with webmail program to view their mail, so they don't have to have any software on their devices, and it's a pop-in SMTP server, and so they can use pop-in SMTP to access the mail on the particular server. So it's there. It's interesting for our particular user base, our cruise ships and so forth. This is great because they can provide passenger email without having to actually consume any airtime because they're doing textual-based email that is based on the router, and that gets sent out very, very efficiently over the link. There's an entire manual that describes this. There's also a video which describes everything about this particular email service. GPS tracking is a very interesting feature. It uses GSAT track, and so you should have a server that basically would work right out of the box with this tracking service, since we also use GSAT track. The tracking server is very interesting. It uses a GPS on the fleet broadbands to sample the position, and then it sends that over the link to the tracking server to be displayed on a tracking website. And so global satellite tracking is a very, very nice tracking service, and that works great. And by the way, the router also uses the fleet broadband to access its time. There's no battery in the router, so when the router boots up, it actually queries for the time, and that's how it sets its time, is by querying the terminal. We can do tracking by reading the GPS on the terminal. So to turn this on, you just specify the tracking interval is 25 bytes, so it consumes no airtime really. The airtime is free, and then you just specify that you've got a fleet broadband, and then you just hit save, and at that point you're sending tracking position reports to the GSAT track. We have a full tracking server that will track fleets, and this is a very nice tracking device. The GPS repeater and NME repeater, now this is a really cool feature. Basically what we can do is we can use the fleet broadband as a GPS source, and then we broadcast NMEA GPS information via Wi-Fi, which means that you can now use this device to drive your boat. You could use an iPad, for example, with a navigation program, or you could use Mac-C on a PC or Nobletech, and it would receive the GPS position not from a GPS, but from the actual satellite terminal, and then you could use that to drive your boat. And so that's a really very cool feature. You can also, if you wanted to, feed NMEA data through the USB port, and you could broadcast that over Wi-Fi, and also it just becomes an instrument repeater for your particular vessel.
Brilliant. How can I test this? I need to download one of those applications, but how do I know that that application is using this feed, not any other feed?
When you configure the application, you would tell it where you wanted the feed from, and then it would report back, and it will actually display it to you, and then you would basically see that coming in. I mean, this is what I use to drive my boat. So I've got an optimizer on my boat, and I just basically repeat the GPS information through Wi-Fi, and I use an iPad to drive my boat.
Which one is the application you use?
I use iNavX on an iPad.
All right. I think I remember that one. Yes, that's about $39, correct?
It's $49. That is correct. There are other GPS applications that are a lot less expensive, but the iNavX is a charting program, which will present maps and allow you to drive your boat. I mean, it'll give you charts, and it'll put your boat on the charts, allow you to create waypoints and routes, and it uses this particular feature.
Wonderful.
There is a USB port. The device does know how to communicate with USB-connected satellite devices. So you could, for example, if you ran into trouble, you could use your GPS phone, your iSat phone, for example, to do email through this particular device. I'm also currently working on a GSM GPRS interface so that you can use a GPS dongle and actually use this as a shoreside-based router using GSM and failing over to your satellite system. And that's just a new feature that we plan to add as an add-on feature to this router in the future. The other tabs are status information. So this is basically how much memory the router is using, your SSIDs, who's connected via Wi-Fi. This is all status information. The only one that is really of any interest here is the system log. The system log will report any kind of error messages and so forth. If there's any errors or problems with the router, it's very helpful for the support people to have access to the system log. Real-time graphs are very nice. This will actually tell you right now, this very second, how much traffic is being used by the different interfaces on the system. So if you go to traffic, this is the LAN Wi-Fi traffic. Of course, I've got nothing connected. ETH1 is my WAN, and I can see real time how much data is being in. So you'll notice each one of these little pulses is actually the data coming back to display this graph because I'm connected to the WAN port. You can see immediately what's happening with the thing. And so status information just on the current status of the router. System configuration parameters here. This is where you set your time zone, where you set the router password. So if you want to change the router password, you would do that. Profiles, it's a very interesting one. It allows you to memorize the settings on the router and give it a name. You can go through and you can spend as much time as you want to pushing all the buttons on the router, getting the router working perfectly for you. And then you can push the add button and give this a name, captive portal, for example, plus no proxy. And then give it a description, captive portal on with no proxy service. And then you would just basically hit save. And that would create a profile for you that you could then export. And then you can import and apply to your router. So it gives you a way to create all these different settings and setups and save them and then import them back up. So you could have 4 different profiles that they use, and that's all they do. And so they create these profiles. They spend a lot of time creating the profiles, and when they ship their routers out, they ship them with the 4 profiles, and then the installer can just go in there, select which profile he wants, and then just install that particular profile. So it's a very nice feature for cloning the routers very quickly.
You remember when I said that I typed in google.com
Yes.
and it didn't do anything? It didn't even give me the red port logon screen.
Yep.
And then I realized after practicing a few times that once I had enabled my Fleet Broadband Terminal to actually auto-connect to the outside world,
It works, yes.
then it worked. So
Yes.
even though I'm connected successfully to the Fleet Broadband Terminal, but if that is not seeing the outside world, it would not activate the captive portal.
Well, first of all, you have no DNS. So nothing is going to work. In other words, when you put in google.com into your web browser, it might get you to the captive portal and you log in, but it's going to try to redirect you to Google. And first of all, I can't get the IP address of Google, and there is no path to Google. So yes, to use this particular router as it stands now, you must have the Fleet Broadband up and running. Now, this particular product is a very generic product that works over all broadband satellite devices, and so we've purposely not put in anything specific like that into it.
Okay.
And the quick start guide should say that the terminal needs to be configured for automatic network connection. So right now, I mean, the router doesn't know if we're really talking to a Fleet Broadband, if we're talking to a VSAT system. I mean, it just doesn't know. I mean, it's just assuming that there's an internet connection. And so we haven't given it any intelligence because there's a lot of devices out there, and so we didn't want to complicate the device. A lot of our users want to bring the PDP context up manually. They want the router offline, period, because they don't want anything going over that thing until the captain logs in and enables the PDP context. And so it's dangerous to play with the PDP context automatically in the background. One thing that you can do, which is very simple to do, is if you go to Network Diagnostics and you do a trace route, that will give you all the IP addresses in a hop to a destination. That way you get to see them all. I'll just do a trace route.
I've just done it as well.
So there's the IP address of the router. There's the IP address of my first hop, which is my static IP address, and then all the way through. So if you do that, you will see all the IP addresses in the chain. If you're going through SATCOM, you'll see 2 or 3 internal routers before you actually hit the internet. So there's diagnostic tools here that allow you to do that. And then ping, of course, is another really, I mean, you've seen ping. You've used that one. That one's a very nice one because that actually tells you that you've got IP connectivity to the Fleet Broadband or to a remote host. I want to get to the network tab because the firewall right here under network firewall is a very important one. This is where your firewall lives. And you will see the traffic rules listed under traffic rules. And so this is the firewall. These are all the rules that are on the router that will allow you to enable and disable ports and IP addresses, and you can create rules and you can add rules and you can delete rules any way you want to. By default, we have 5 rules here that say do not modify. Those are rules that the captive portal and the proxy server automatically enable and disable to kind of make things work without having the user come with the table. But for example, this very top one, it says all does exactly that. If it is enabled, you have the firewall totally open. All traffic will go through the firewall. If you want to disable that traffic, you can just uncheck that and hit save. And at that point, the other rules start taking precedence. And the way this works is rules are evaluated from top to bottom. As soon as it hits a rule that matches, it will stop. So the next one is DNS. Do you want DNS? No. Yes or no. Do you want HTTP? Do you want HTTPS? Do you want FTP? And so these are all things that you can enable, disable very quickly. And then, of course, you can always go and create a custom rule by going to the bottom of the page and saying add. And by doing this, you can now specify, give the rule a name, my rule. You can specify the protocol. You can specify the zone, which interface and or the LAN or the Wi-Fi, the source IP address, the destination IP address, the port numbers, and so forth. And so this is just standard firewall stuff. You can just create rules that would then be applied to the list, and you would put them at the top or at the bottom. So basically what happens is rules start processing at the top, and as soon as they hit one that matches, they will stop. And so, for example, here's a rule that says allow HTTP. Well, here comes the first rule is disabled, so we're not going to do anything. Is my traffic HTTP? Does it match this rule? No. Is HTTP? Does it match this rule? No. It's HTTP. Ah, look at this. From any host in any zone to any host on any zone, port 80. I have a match. Accept forward, allow, HTTP is now allowed, it will go through. So there's an example of flow through the firewall for HTTP traffic. If I have this disabled, then what will happen is it'll keep trying to match rules. So it'll fail, it'll fail, it'll fail, it'll fail, it'll fail. It'll go all the way to the bottom. And the very last rule is a reject rule. And so therefore HTTP will be rejected. HTTP traffic will not be allowed. So I can disable HTTP traffic by disabling the all rule and by disabling the port 80 rule. And then boom, at that point I've disabled HTTP traffic. Again, I can do the same for DNS. I can do the same for HTTPS or for any other protocol that I put in here. So there it is. It's a full-featured firewall that you can customize to meet your particular requirement. I really don't see users really messing with this very much. They've got the cat portal, they've got the proxy server, so that that pretty much gives them all the control they need. But if they need even finer control, then they can go ahead and play with these particular rules.
Cool, wonderful.
That's pretty much it. I mean, we've gone pretty much over the router. There's some advanced configuration that we can do to lock down the router completely to prevent Skype and everything else, but I think we should probably call it a day.
Thank you so much.
You know, it's a complicated little box, but, you know, hopefully it's pretty simple to set up, and just out of the chute, it should provide connectivity.
Wonderful, Luis. That's wonderful. Marco, are you okay? Happy?
Yeah. I'm seeing possibilities here. So,
wonderful.
For more information on making airtime count, contact globalmarinenet.com. Thank you.